Hi everyone. In this video, I am going to be going over some of the content from Chapter 10 in the CCNA Routing and Switching Study Guide written by Todd Lamel. I will be doing this in Packet Tracer for the recording. At the beginning of the hands-on labs, there is a network topology depicted there. So if you are following in Packet Tracer, you will want to go ahead and build your topology to match with that image. It should look something like this. So we have 3 switches, multiple connections for redundancy purposes between each switch, a few devices on the end, and a single router. We're not going to touch the router in these activities, I don't believe. We're mostly looking at layer 2 switching and some port security protocols. So if you need to, please go ahead and pause the video here, get your topology to match this. Let me see if I can show port labels here. It's a little bit hard to tell. Switch 1 up here. Port 15 is going to port 1 down here. Let's see if I can make this any easier to see. So if that helps any, 15 and 16 go respectively to 1 and 2. 17 and 18 go to 1 and 2. And then 5 and 6 meet 5 and 6 between these two switches. So it is kind of hard to tell because they're all kind of clustered right next to each other. And then we have PC. The first PC is going to port 3. The second PC here is going to port 4. On this switch, our first PC is going to port 3, and our second is going to port 4. Alright, so once you get that cabled, we will be ready to begin actually doing some configurations on these. As per the book, we're going to go through some basic stuff like the host name, banners. We're going to do some interface descriptions, which is always a good idea, even in a production environment. It can save you tons of time when you have to troubleshoot. The book recommends setting up passwords. I'm going to skip that. In a production environment, you would want passwords. For a test environment, I don't want to go through the extra hassle for nothing. And then we will also configure an IP address, subnet mask, and default gateway. We'll be setting up a VLAN on each. Actually, I think we'll be using the default VLAN, VLAN 1, on each switch. Alright, so to begin, we're going to start here at the top for switch 1. And I'm going to have, okay, display name's already good, so we just need to come in and give it a host name to match S1. Here's where you could put in your password security steps if you wanted. Enable a secret for Cisco or whatever you would want to do there. I'm going to go ahead and jump right into my interfaces and start putting descriptions down. And so 15 is the first connection to switch 3. That's right, switch 3, 15. It's not showing me my port numbers now. Yeah, so 15 and 16 go to switch 3. And then do the same thing here. To S2. Alright, so we have our descriptions done. We also do have this connection here. I'm going to go ahead and label it as well, or put a description on it. Per the book, IVR, that would end up being our gateway router to the internet, something like that. Or maybe one of our routers leading to our other router to the internet, whatever the case may be for your production environment. We'd also want to set up a little bit of security here. We would want some sort of password or a secret. If you want to do that, you can just do something simple, password Cisco, give it the login command, and I like to give the logging synchronous so that system messages don't interrupt my commands and break my commands in half, so they're split between lines. It doesn't actually affect programmatically, but it doesn't make things very fun to look at if your commands get split apart. So we'd want to do that for the console line. We'd want to do that for line VTY015. And these should probably be different passwords in a real environment and a lot more secure than just Cisco. Alright, and then we'll want to do a little bit of work with the VLAN, and we're using the default VLAN 1 again, and in a real environment you should probably switch that to a different VLAN and use different VLANs. Ignore VLAN 1 and don't use it for anything. And the reason is the default is VLAN 1, so if anybody's trying to get into your network, that's likely to be the first place they'll check, is to see if VLAN 1 is active and try to get in through VLAN 1. So if VLAN 1 is disabled, then they have a few thousand other ones that they have to go and check. So we're going to assign IP addressing, and this is all based on a /28. Go ahead and bring VLAN 1 online. We'll go ahead and set a banner message of the day. We'll just say this is S1. Alright, then we'll go ahead and save the current configuration to NVRAM. And we're all set up on S1. So let's go ahead and remove port labels, make it a little bit cleaner. So we need to go ahead and do the same thing for S2 and S3. The only real difference is that the IP addresses will be slightly different. So on switch 1, the IP address was 192.168.10.17/28. On switch 2, it'll be 192.168.10.18/28. And switch 3 will be 192.168.10.19/28. I'm not going to run through all those configurations. I'm going to go ahead and pause the recording and get that done. If you need to, please pause the recording right now and do the same. It's pretty much the exact same configuration we did on switch 1. We're just changing the IP address for the VLAN. Alright, if you are having any trouble getting these switches with their basic configurations, you should end up doing something like this. So this is switch 1 and the commands that you give. This would be switch 2. And again, these are optional. And this is switch 3. So if you need to use those, please feel free to do so. Go ahead and pause on whichever one you needed. And once you are done, go ahead and resume, and we will continue from there. Alright, so that was 10.1, which is the basic configuration. Next we want to do 10.2, which is actually verifying the layer 2 switches. So we're going to start on S1, and we're going to give the command show interface VLAN 1. I'll make this a little bit bigger so we can actually see everything on here. So we want to make sure that the management interface, the VLAN 1, is up and working correctly, that it has the correct IP address assigned. Alright, so when you know you have that configured correctly, then we can move on to step 2, where we give the command show MAC address table. Currently, it's only showing 1. We haven't had any network traffic moving through this network at all yet. So as we start pinging across devices, we should start building this MAC address table. So we can do that really quickly, but I want to go ahead and verify what we currently have. It's entirely dynamic. We haven't set any static MAC addresses for anything yet. So we have a few on switch 2 and on switch 3. We've got 3. Alright, so one more thing that I haven't mentioned is that we need to set some IP addresses on these computers so we can have them create network traffic for us. So I'm quickly just going to create a basic class C for this network, and we're just going to use 50, and I'm going to start my computers at 25. We can do that here as well. '26. Sorry, this will be 27 now. And 28. Alright, so let's do another quick look. I'm just going to do a quick show run on switch 1. So we can see our descriptions. Looks good there. Our VLAN 1 IP address, our management lines for configuration, etc. Alright, that looks fine. We'll also issue the command show IP interface brief, and this way we can just review and see, make sure that our ports are functional. Down just means that they are not connected, there's no cables connected. So here we have up and up, which means we're good. 15, 16, 17, and 18. So on switch 1, these are the 4 links to the other 2 switches. And there's our VLAN interface IP address. Alright, so let's see if we can create a little bit of network traffic here. So we saw on switch 2 that we had these 4 MAC addresses on the table. Now that we have a little bit of network traffic across that switch, we have a couple more entries here. So we had 1, 2, 5, and 6, and we have a few duplicates, so 5. And we'll take a look at why that is in just a second. But first, let's grab an or a MAC address for PC2. It's right here. And so that is the MAC address for PC2 on that switch. The first PC, really, on that switch. And this should be the MAC address of the other PC on that switch. And the only reason it learned it is because those two had an echo request between the two of them. So then if we come over to switch 3, we see that it has built more of a MAC address table as well. And we should be able to find PC0, which I believe is that one right there, and PC1. Right there. So we might be wondering why we see this MAC address from this computer on this switch. Let's hop over to simulation. We'll clear those. Well, let me shrink that down any. It's okay. What happens when we ping? Now that the switch has the MAC address, it'll deliver it directly. Before the switch had the MAC address, it had to send out a broadcast, essentially. It had to flood that ping out every port, which means that it came across to switch 3. Let me make sure my devices are in fact saved, and we'll cycle power to clear the MAC tables and verify that. So we'll bring everything back up. Alright, so we're back down to our minimal, so it's been cleared except for what it immediately knows about. So now if we were to run a ping across here, it comes up to the first switch, and the switch doesn't have the MAC address in its table. So it floods it. And that is how switch 3 then learns about this computer over here. It says this MAC address can be found by going through this connection. And of course switch 2 learns about the MAC address because when it floods it, it receives a reply from PC3 saying, that's my MAC address, which then allows the ping, the echo request, to complete and return back to PC2. And so the same thing will happen on this side. If these two try to ping each other, until S3 knows the MAC addresses for these two, it will flood, which means that switch 2 will then be able to learn about these two machines' MAC addresses. And then the echo request will complete. So that way they're getting updates not just from the directly connected computers and devices, they can actually get from across other switches and build their MAC address table that way as well. Alright, so that should pretty much complete 10.2, verifying the layer 2 switches. We've looked at the VLAN interfaces to make sure that they were the correct IP addressing. We've looked at our MAC address tables, and we've looked at our IP brief, show IP interface brief rather. So we're ready to move on to 10.3, which is configuring the actual port security. Out of all the labs in this chapter, this is probably the most important one to fully understand. The others have just kind of been IP addressing and some basic connectivity. Port security is pretty important in most environments. So to begin this, we're going to begin on switch 3. We're going to come up to the configuration level, and we're going to start on interface 3, which is to this first PC here. So in order to enable port security, we first need to give the command switchport mode access. When a switch is shipped out of the box, it is switchport mode desirable, which will allow it to immediately understand and pick up a trunk connection between switches. But in order to enable switchport security, we want to switch that over to switchport mode access for the end devices. You would also want to do switchport mode trunk specifically between your two switches if you wanted to set up switchport security between your switches on the trunk links. Alright, so we've done that. The next command we want to give is switchport port security. And so this will enable port security on that interface with default settings. So we can view those. with this command, now that we have it established, let me add that in there, do show, and we can see that port security is enabled. Violation is shut down by default, so if it learns of the first MAC address and then something else tries to connect with a different MAC address, it will shut down the port completely. It won't just ignore and drop the packets, it will completely shut the port down, which means that as an administrator, if somebody else tries to connect to this port with their device and it shuts the port down, you then have to come back in, give the port the shutdown command and then the no shutdown command to bring it back online. Again, so we see the maximum MAC addresses is 1. So that second MAC address that tries to connect on that port will immediately shut that port down completely. We can change those settings. So we can give the command switchport port security maximum of 2 or 4. If you have a user that's swapping between multiple devices for whatever reason, they need a physical LAN connection rather than being on a wireless network, then they might need to be able to plug in 3 or 4 devices to that one port at random points throughout the day. So if you're configuring that, keep that in mind, that the user might need more than just 1 or 2 devices on that connection. It's not great for security, but the end goal in IT is to enable your users, your end users, to complete their tasks as well. So whatever you need to do to enable that, or maybe add another line and give them 2 static lines, again, it's entirely dependent on your specific network. Just something to keep in mind. You can increase that number. Alright, and then in addition to completely shutting the port down, because if this is set to a maximum of 1 and they've switched to a different machine, and plug a different machine into that port, it'll shut the port down on the switch. So then if they switch back to their original computer with the correct MAC address, the port is still shut down until you as the administrator go and re-enable it. So the alternative that is a little bit less hands-on for the administrator or whoever's managing this network, we can give the command switchport port security violation, and there's a couple of options here. So shutdown is the default. Restrict will drop the packets if the MAC address is above the maximum. So if it learns of 2 and the maximum is set at 2, then the third one that connects, it will just start dropping those packets from that third source. If you're logging or auditing at all with that third MAC address, every time it drops a packet, it will then cause the security violation counter to increase by 1 as well. The third option here is on the top, the protect option. This will drop packets from that third source, whatever's over the maximum. It will just drop those packets, but it won't necessarily increase the security violation counter. So we're going to set this to violation restrict, which is one step down from shutdown. So this way, if they connect a known device, their original computer, they can still use the network connection with that original computer. But it will log and notify us that, hey, there was a violation on this port. So that way we know as administrators, this user had this connection and somebody tried to connect to it with a different device. If you don't plan on doing any kind of logging or monitoring of that, and you want to reduce it just down to protect, you are more than able to do so. That way it won't use any additional overhead to log those violations. It will just drop the packets if it is a violation, and that's it. Alright, so let's go ahead and do show port security. We see that it's only enabled on 3, because that's all we've set it up for, was towards this computer. And there's the security action is restrict, rather than shut down. So we can also go ahead and just to verify that, we can give the command again, do show port security specifically for interface 3, and we double check that violation mode is set to restrict rather than shut down there. So it's important to understand the different violation modes, these three, what they are, what they do, how they're different, understand that you can and how to increase the maximums, as well as how to configure and why you would need to configure switchport port security. I believe that covers all of the hands-on labs. I think I went over most of the content fairly quickly. If you have the book, it does go a little more in-depth to some of the key concepts. So if you have it, definitely read it. Don't just count on these. But thank you so much for watching. As always, if you have any questions or comments, please feel free to leave them for me below. I will try to reply in a timely fashion. And I hope to see you all in my next video.